Hello everyone, and welcome to the part 2 of the classification of polymers. Now in the part 1 of classification, we have discussed the two types of classification. That is, the first one is based on the source of availability with natural, synthetic and semi-synthetic polymers, and on the basis of structure we have discussed the linear, branch and cross-link or network type of polymers. Therefore, now in this video we'll be discussing the remaining two types of classification of polymers, that is based on molecular forces, and the fourth one is based on the mode of synthesis. Therefore, the third one, based on molecular forces. Now, this type of classification is also further classified into three types. Now, the first type is elastomers. Now, what are elastomers? Elastomers, they are rubber-like solids with elastic properties. Now, since in elastomers, we all know what elastomers are, because the elastic rubber bands that we use daily, especially the ladies to tie their hair, they are rubber-like solids possessing elastic properties, because in this type of elastic rubber bands, the intermolecular forces of attraction is very low. Therefore, they can be stretched to any extent, and therefore they exhibit the property of elasticity. And therefore, this type of examples of such type of rubbers are known as vulcanized rubber. And in this type of polymers, the forces of attraction is weak van der Waals forces of attraction. Now, the second type is fibers. Now, in the fibers type of polymers, they are thread forming solids. These are the fibers are the thread forming solids. In this type, though they have van der Waals forces, both the elastomers and fibers have van der Waals forces. Elastomers have weak van der Waals forces, but in fibers there is strong intermolecular forces of attraction, that is strong van der Waals forces of attraction like occur in the fibrous polymers, and therefore they have strong intermolecular forces, and therefore they cannot be stretched so much, but they have a thread-like property of solid, and therefore they are known as fibers. For example, this type of fibrous polymers are nylon and terylene, or this is also known as polyester. Now, the third type of classification is thermoplastic polymers. Now, thermoplastic polymers, the force of attraction is intermediate. Okay, the force of attraction is intermediate between the elastomers and the fibers. That means the thermoplastic polymers, the forces of attraction is in between that of elastomers and fibers. That is, the forces of attraction here would be a hydrogen bond or double bond. Therefore, they have intermediate forces of attraction between that of the elastomers and fibers, and on heating they become soft, and on cooling they become hard. That means thermosetting polymers are also known as reusable polymers. For example, PVC, polythene and polystyrene. This type of polymers, they can be made into any shapes, because on heating they become soft, and on cooling they become hard. Therefore, these type of polymers are reusable polymers. Now, the fourth type of polymer is thermosetting polymers. Now, this is a polymer that cannot be reused. This is a reusable polymer. Thermoplastics are reusable polymer, whereas thermosetting polymers are not reusable. They have cross-link, or they have heavily branched molecules or chains are present in thermosetting polymers. Therefore, they cannot be reused. They have a three-dimensional structure because the branch chains are cross-linked to form a three-dimensional structure. For example, bakelite, melamine, etc. And in thermosetting polymers, there is strong covalent bond. The forces of attraction in thermosetting polymers is strong covalent bond. Therefore, on the basis of classification on the molecular forces, it is of four types. The first is elastomers with weak van der Waals forces. Example is our vulcanized rubber. The second one is fibers. Strong intermolecular forces of attraction is present in fibers. Example, nylon and terylene. They have thread-like property. And then the thermoplastic polymers are reusable polymers. They have hydrogen bond and double bond. And the forces of attraction of thermoplastics is intermediate between that of elastomers and fibers. Example is PVC, polyethylene, polystyrene. And the thermosetting polymers. They are the polymers that in thermosetting polymers the chains are heavily branched, forming a three-dimensional structure, and therefore they cannot be reused, and they have strong covalent bond. Example, we have here bakelite and melamine. Now the fourth type of classification is based on the mode of synthesis. Now on the mode of synthesis, it is of two types. The first one is addition polymers. Now, what are addition polymers? Now, addition polymers, the monomer units have double or triple bond. Okay, the monomer units, the addition polymers, the formation of addition polymer. For the formation of addition polymers, the monomer unit should have double, or the monomer have double or triple bond. For example, our typical example is our polyethylene. Addition polymers are the polymers formed when the monomer unit, that is the starting smaller unit, have double or triple bond. Therefore, N times of ethene undergo they chemically combine or undergo polymerization reaction. N times of CH2, the C combine N times to form our polyethylene polymer here. Therefore, in the addition polymers are the type of polymers where the monomer units have double or triple bond. One point to be noted here: all the homopolymers are addition polymers. In the first type of classification, I've discussed what are homopolymers. Therefore, point to be noted here is that all the homopolymers, all the examples of homopolymers that I have discussed in the first video are also known as addition polymers. And in this type of reaction, no elimination or removal of any atoms or molecules takes place. In addition polymerization, there is no removal or elimination of any atoms or molecules, but there is breakage of this bi bond, and then the monomer unit goes on acting again and again to form the polymer known as polyethylene. Therefore, this is known as addition polymer. Now, the second type of polymers under the classification of basing on the mode of synthesis is condensation polymers. Now, in condensation polymers, there is elimination or removal of molecules takes place, and molecules such as water, ammonia, alcohols, Next place, there is elimination of molecules. In addition polymer, when there was a formation of addition polymers, there was no removal of any type of atoms or molecules. But the only difference between addition polymers and condensation polymers is that in condensation polymers, polymerization, there is elimination of molecules such as water, ammonia, and then alcohols. And for example, nylon 6,6 is our condensation polymer. Therefore, nylon 6,6, the monomer unit was adipic acid and hexamethylene diamine. Therefore, when our adipic acid reacts with NH, let me write one H here, NH2, it's the same, CH2 6 times, and then NH, one more H, let me write here. Now there is removal of n molecules of water. That means from here, the OH, there's removal of water. Even from this, the H from this hexamethylene diamine, since there are n molecules of this adipic acid, there's removal of this H removes this, and there's removal of n molecules of H2O, and there is formation of our nylon 66. Would look in this. This is our nylon 66 molecule CO. There will be only CO, and then our NH would come and join here, CH2 6 times, and then NH, and then therefore this is our nylon 66 polymer. Therefore, the only difference between our addition and condensation polymer is that in addition polymers, there was no removal of any atoms or molecules, whereas in condensation polymers, there was removal of molecules such as water. An example is given here for the formation of nylon 66, and then there is removal of ammonia and then alcohols.